So we're putting something into this capacitor. This is a capacitor. Overall, the technology starts with a classical power supply. It goes in and charges a capacitor. And then it goes to run a motor. This is classical. This is classical. Everything that is non-classical takes place right here. Now, he was claiming to generate cold electricity. Whatever cold electricity is, it can be stored in a capacitor. It's not a wave, it's not a scalar wave, because I don't believe you can store scalar. So some sort of anomalous particle was being developed in this technology that was storable, and from the speed of the motor, like it had a lifetime of at least 30 milliseconds. So you can store it for that length of time. Actually, there's indication they last as long as 30 milliseconds. One of the experiments is the popping coil approach. It took 30 seconds to charge the capacitor up with enough of this energy to make the popping coil thing work. So 30 milliseconds is a minimum, but it could have lasted at least as long as 30 seconds. So we're putting something into this capacitor. Okay, now the patent at making this is a little more complex than what it looks. The patent. Oh, thank you. The original 1973 patent involved two power supplies, which were center tapped high voltage coils. It went out to diodes. This is what's disclosed, but this isn't everything that's there. They went to these two coils, then they went to the capacitors that were alleged to be tied together like this. Okay, and then from here we have the switches that finally went to the utilization of this energy. This is not the whole circuit. They left a lot of the stuff out and certain aspects of it. First of all, these capacitors do not hook together to ground. The important thing is here, two power supplies were required. You don't see that in hardly anything where you have two power supplies. For this sort of architecture, everything's hooked in parallel. It doesn't make any engineering sense. This gave me long evenings without sleep for years. Just recently, when Al Franco acquired the Gold motor, it came with a power supply. Now, the Gold motor was probably made in '65. This power supply was made much later. It was probably made by Mr. Hackenberger because it's got ICs on it that were not manufactured until 1976. In 1976, they were suffering from financial difficulties, so this thing was probably made in 1979. So even in 1979, this 6 years later, two high voltage outputs. Now he was doing that as he had a transformer with two center tap primaries. That was run by transistor switching. He used transistor switching. So you can go ahead and use transistors, at least it works. And two separate high voltage outputs that went to full wave bridges that were unfiltered. And then he had 2 voltmeters in here that went from 0 to 5,000. So this was the zenith of the power supply that existed for the last motor, the last free energy engine that was ever built. And this is all classical design. You can probably improve upon it. What he needed out here, what was needed up here, was 2 high voltage outputs. And these are probably, I suspect, out of phase, 180 degrees out of phase. So we know that from just the recent disclosure of that power supply. Now these things here were pulse width modulated, the transistors were, so it's probably not a symmetrical, it's probably the pulse width or the, I forget the term. Anyway, the spacing between the pulses was probably not symmetrical. Okay, so now that's one. These are all just individual clues that you're going to have to put together on your own here. Let's go back to that floating flux field thing that shows up in the power supply as two magnetically coupled inductors. And you've seen it on the motor on the EMA4. It was hidden on the EMA6, but it was right here. What we have here is 18 individual conductors, approximately a ½ inch in diameter. Some big stuff. In another photo that I was able to get a couple of years ago, these things are individual turns. You got one turn that makes up this coil. That's not a multiple inductor. It's a single turn that goes on this engine case, one on top of the other. There was 18 power supplies, 18 capacitors, and 18 of these single turn things. So that's another clue, is this is not, it's not that, it's a, like that, two of them, magnetically coupled with each other, right in that position of the motor. And the MA4, they had to make the motor longer to accommodate this structure. And this was an important structure. It shows up 5 times in the patent documents, and there's only one sentence about it in the commentary. And Dr. Chalfin, who wrote up the document, said, it's assumed to be a delay line. Well, since the motor was 16 inches in diameter, you're not going to get a very long delay there unless you're working up in the hundreds of megahertz or some frequency like that. So we have this unusual thing, we have that unusual thing. We're trying to develop an anomalous something that charges a capacitor. So this is about as, there's one more piece of evidence. When one observer came to look at this motor, when it was running, said that this thing would just make your hair go right towards it. Now, Gray described that as being a magnetic field that was 360 degrees around, but he didn't know a magnetic field from an electrostatic field. This thing here was developing potentials equivalent to a mid-sized Van de Graaff generator. The only component on this motor that could contain a potential like that would be these huge cables that were there. So something, even though the capacitors were measured to run at about 3,000 volts with a voltmeter, something was generating some huge potentials there that were not being bled off.
Closer to the order of hundreds of thousands?
Yeah, 100 kV.
Yeah.
I figure what a Van de Graaff does. Even a small one gets up to 100 kV. Some go to 150. I mean, there's no current there, but there's a lot of potential.
I've got one about that large. It gets up to about 500,000.
Okay.
That'll
your guess is as good as mine.
Hairs.
Whatever draws your hair from about a distance of 8 feet, that's the potential.
Okay.
Now this whole thing was isolated from ground. There's no antenna, there's no ground connection. It's all floating.
Insulated.
Yes. Okay, now we're going to talk about the battery. They had problems with the battery. There's 2 sets of batteries on this thing. One provided power for the high voltage power supply. The other one was a fundamental component of the non-classical process. Without this battery, it wouldn't work. The problem they had that when it was in the circuit, it kept blowing up. They spent a lot of time and money trying to find batteries that could handle the pulses or whatever was taking place in this battery.
Mr. McKay, can
Yes.
I ask real quick, and I don't want to interrupt.
Sure,
your
no
thought.
problem. This is all free
Did
run.
Marvin Cole have a problem with the batteries ever blowing up on his device? Or do
No,
we
the
know?
problem started happening when they started to increase the power level.
Okay, so his...
When you're down below 10 horsepower, apparently we're generally fine.
Okay.
There was other problems, capacitors and things like that. As soon as Gray started bumping the power up, boom, battery became a real big issue.
Batteries, okay.
So the demands on this battery is probably proportional to the power level at which you're operating. Once we figure out what the heck the purpose of the battery is, we can probably engineer around it. So they had this problem with the battery. So the battery is a fundamental component of that conversion circuit. When I showed the little black box, I showed 2 batteries. That's because it indicates from the research that you got to have that battery, and it's not because of the power supply. So we got this little clue that you can incorporate. The next thing is that from From a historical standpoint, the original group was called the Electromagnetic Electrostatic, or was Electrostatic Electromagnetic Group, EMA, Associates. The term electrostatic was dropped. Secondly, the little standalone black box was called the electrostatic generator. Nobody has figured out where the heck the term electrostatic applies to this technology. Keep the term electrostatic in your mind, because that's an important historical clue as to what's going on here. When Richard got that motor, the EMA4, when he got it, he had a viewport machined right about here. This plate was 2.5 inches thick aluminum, so this was no simple job, and it probably cost a lot of money. Take the engine apart, take the rotor out, machine this piece, put it all back together, just so he could see what was going on in there. What do you think he was trying to look at? Why would somebody want to cut a hole in a motor at that particular location to see something? I have a technical paper that was written by somebody back then that claims that the whole part of this popping coil thing was done with arcs between the two coils. So that would imply that what was happening here is he was transferring power from the rotor to from the stator to the rotor by means of arcs. That eliminated a lot of problems with having commutator rings and high voltage stuff. But an arc is definitely involved in this technology. In 1973, Gray also comments to another observer that all of his circuits, which were not his, required an arc. And I believe that. Even the converter element switching tube, I believe, was an attempt to get the arc out of the motor off to the desk so that they could use permanent magnets on the rotor. It was a workaround. It was an improvement. Richard Hackenberger went for it, but the only problem is it only has a very limited power range for that technology to work. And it fell on its nose inappropriately and cost them their funding. So here's another clue you can put into it that has got photo documentation behind it. Now, would you like the speculations?
Yeah.
Consider, in 1989, Peter Lindemann and Eric Dollard made an interesting video about Tesla longitudinal electricity. What they had was a diathermy machine, which is essentially a Tesla coil that went to a capacitor, which went to two spark tubes that were diodes, gaseous diodes in a very limited range, which then went to the primary of a coil, 2 turns, and they had a 20-turn secondary. This was a one-take a wonder, he describes it, and the experiment that they did here was just ad-lib, well, let's try it out and see what happens. The end of this thing here is hooked to a NE4 neon bulb, which is a 9-watt neon bulb. Down here at the bottom, it goes to another coil, which Eric just recently described as to what it's composed of. And then the thing that's interesting, it went to a vacuum machine, sewing machine lamp, with this little filament in there. He was able, when Tom Brown put his hands over this, he said he felt the pressure coming off this thing. So they put a strip of copper foil out here, and the foil was attracted to the lamp. Well, that's interesting. And what really is interesting is they put a doorknob capacitor with no antenna, just the terminal that's on the capacitor, connected it to ground. And this sucker charged up when it was down here, kind of close to the film. It didn't charge up as much up here. You probably have to find the sweet spot. There's probably about a half inch to an inch difference. And there's little streamers flying off in here, like a Tesla globe. This thing would charge up in about 3 to 6 seconds with enough power to flash an NE2 light. So that means at least got up to 90 volts. And I'm classically trained. I don't know what the heck's going on here. I mean, we can come up with all kinds of speculations. I know that if you have open sparks, if you didn't have the enclosure here, you'd get a positive charge because of the effect of the streaming streamers have a positive charge on the front end, and you could possibly collect that. But this is basically an AC device that's charging a DC capacitor. How this works, I don't know. I just acquired one of these machines here, so I'm going to be redoing all these experiments.
And what is that?
This is a 1920 diathermy machine.
Diathermic?
I believe in the video they called it a Fisher
Fisher, yeah, that's the
medical
manufacturer. This is a Model A,
Yeah.
4-gap. So it's a Tesla coil by itself. I don't know if Peter thinks the anomalous process is taking place way back here in the Fisher diathermy machine. We've got all these spark tubes, this capacitor, we got this coil set up here. But anyway, something is charging this capacitor with a system that has that's open circuit. This is not our classic closed loop Kirchhoff current equation device. This is something different. Now I've set up this coil right here with 2 turns, and when you pulse it with the coil, it resonates at about 2.5 megahertz with this kind of capacitor. So that's the frequency that's being generated. Not super high, but nevertheless we do have definitely an ACH field that's being generated here. So, what's going on here? Well, even things that are not, you have to look deeper here, and this is where I'm really out on a limb. I'm trying to predict something that I haven't done the experimentation on. But the secondary is wound with Teflon-coated, silver-plated copper wire. He used coax. The important thing is the Teflon. The Teflon is a dielectric that is also an electrode. When Tesla, we'll go back to Tesla history here, when Tesla talks about all his fancy machines and several patents, he has a primary, he has a secondary. And when you look at those patents, there's nothing to them. He's got one little bulb here, and he's got a little bulb here, and a little bulb here, and then he has 6 different types of circuits that he hooks up there. He describes this circuit as the local circuit, this circuit as the working circuit. The line of demarcation is between the primary and the secondary. And he don't talk about that too much for good reasons. But when you read some of the constructions, how these things were built, he was using a insulation medium here that was pine rosin, beeswax, and 5% carnauba wax. Now that's the classic formula for a very effective electric. So this material is not only a dielectric, it's an electric. Plus he's doing spacing in here. He's filling these spaces up with cotton. Then he's impregnating it, and he's spacing them way far apart so they have lots of this dielectric around there. He says that's to reduce the capacitance of energy. Well, it probably does that too, but I think it does a lot more. So here we have Teflon, here we have an electrode. Gray's favorite plastic was stuff called Delrin. In that 1986 video, he made a big deal about these magnetic cores out of Delrin. He didn't know a magnetic core from a piece of grass, but he did remember that name. I suspect that Marvin Cole was using Delrin in his system, and he either discovered this by accident, or it was pointed in this direction by whatever information they got in 1957. But
and what was he using the Delrin as?
Well, in this case, the floating flux field. What is in those cables? What is between those cables? That seems to be where the action is taking place, because when Hackenberger made the next public motor, it didn't have that floating flux field. I'll show you what he had in the speculations. There's probably a lot of other things you can use. The side view of that EMA6 motor, you had the motor up on top here. Then you had the cart. You had the 3 big transistor switching power supplies here. You had the batteries down here. You had things that are held out to be capacitors here. And then you had the converter element switching tubes there. Well, that was all the major subsystems of that device.
This was the machine that did not work.
This is the did not work. Yeah, that did not work in 1976, but did work in 1977. So
okay.
They had most of it there. Whatever he did, tweaked or tuned, he. And I'll explain what the difference was.
Okay.
These are the classical power supplies, just like this 1979 power supply that's been retrieved. So you probably wouldn't find anything there. These were probably made by a local fabrication shop. You have these things here that were held out to be the heart and soul of the technology. But there was 2 PhD engineers on the board and 3 lawyers trying to get money. Do you think? And they had no protection on that thing. Absolutely nothing. They'd just gotten the patent for this part of the system, but nothing on that. Do you think they're going? And here's a room full of 150 people, technically competent, with cameras, looking at this thing. This thing's built in a plexiglass box. Now, how realistic is that? If these lawyers knew anything about it, they wouldn't let that bit of information be disclosed if that was the heart and soul of the system. Well, the fact is it wasn't, my opinion. It was a red herring, a piece of eye candy there, so that people wouldn't pay attention to that device. This device here was a great big huge capacitor drawn full size. It'd probably be about like that. The top had 4 insulators on it, so it wasn't a standard capacitor. It was big, it probably had a capacitor in it. But according to Rocky, Gray had all his capacitors and things custom manufactured at an outfit in Thousand Oaks, California. This was probably something else. This is probably a passive, it could be a pulse forming network, it could be a low pass filter, it could be anything that a company like that could put together. I maintain that the conversion from the classical to non-classical took place in this device. Maybe the bottom half was a capacitor, and the rest of it was the missing floating flux field device with its proper integration with an active dielectric. That's the speculation that you can go forth with here.
Floating flux field.
Floating flux, that was what was on the outside of the motor in the who knows what it means. I don't think it means anything. It's just, that's how they described that component, because it was in all the drawings that they didn't take time to erase. And the photographs.
Not to be confused with a flux capacitor.
Yeah. This is something, you can give it your own name. You get it to work, you can name it yourself. Later, to get this engine to work, they got rid of this part, which failed, it didn't work. It was never used functionally ever again. The switching tubes, yeah, those circles were the switching tubes, the 3.
They don't work?
They don't work, at least that's from what the historical record shows. He replaced it with a expanded commutator out here that has 3 sections. When you see this thing running, it's arcing and sparking. And he told the photographer at the time that that's where the action was. The more of them donuts there, the more power he got out of it. Well, what you got here is the same thing that he was looking at in that window on the front end of the EMA4. Those arcs were being stretched. So from my analysis, it's a 2-step process here. The converter can generate the anomalous particles and maybe some energy at a COP of about 4, but you store it in a capacitor, run it through a stretched arc, and you get a heck of a lot more out of it. So just figuring out the converter is only the first part of the challenge. Then you got to figure out what this arcing procedure is. I think it's a lot simpler. And then you run it through a magnetic rotary converter to get the torque. So, and as far as I can tell, in the original EMA4 motor, he put these things on the outside of the motor here so that when these huge magnetic fields pulsed, he would, because that's all this thing does. The primary just generates a huge field. Well, the motor did the same thing, so he got double his money back, so he had a little bit of a feedback process there to increase the efficiency. Hackenberger probably figured out he could do it well enough just by getting the flux field off that motor so nobody could see it. Anyway, that's all speculation.
Are you putting on the internet, like a website?
I've got a phone connection to the internet. I can't even see YouTube videos, and my internet connection at work is highly regulated. Besides, they would probably can my ass if they knew what kind of emails I was sending. Okay, now I'll go into the speculation of how this all puts together so that if you have the incline, you can do this. It involves 2 Tesla circuits and the Marvin Cole circuit that we talked about a little earlier here. I'm sure you've all seen the Tesla diagram where he has the transmitter and receiver that goes down to the spiral coil. and then it goes to ground. And then he has his generator, which he describes in other patents, which makes a 2-turn loop around this thing. And that's his generator. And it is generating radiant energy or whatever he had out the top of it here. Nobody has ever figured out exactly how, because they're not looking at the dielectric that's involved here and the geometry of this thing that would take advantage of that dielectric. He also has a receiver that's designed the same way, quite a bit the same way, because back then you had to submit the receiver and the transmitter for any radio patent. Couldn't submit them individually. So he has the single, or the 2 coils. Then he, let's see, where did that thing hook up to? I think it hooked up to a whole bunch of very amorphous loads, you know. Loads going this way, loads going that way, but that was about it. Then he has another patent where he's got a square plate that hooks up to a capacitor, goes to ground, goes to a switch, goes to an inductive load, and that's his patent. So we're going to take and combine these 2 patents. Well, first of all, this is a transmitter, receiver, receiver. Let's just get rid of this receiver and use this receiver.
Now, the middle one, is that the classical hairpin circuit?
Well, this is the classical spiral with the 2-turn primary on the outside. No, it's not bifilar. At least it wasn't shown that way in the patent. Now, I think that the bifilar does increase the effectiveness of the dielectric utilization. So you'd have to try it both ways. Lots of room for experimentation here. You see, now that I've publicly disclosed all this, you can't patent it. But there's a lot of improvements you can make money on here. So go out and make lots of money. So we'll use this one here. Now this is an elevated plate. We could just as well use one of these primaries because they have just equal amount of surface area. So we have the big primary to take the place of that elevated plate. Transmitter, receiver. Now this whole thing was designed to transmit energy over a long distance. Well, we don't need to go a long distance. We're just trying to get whatever that stuff is. And I propose that stuff is from the dielectric that's been acted upon by the primary. So let's just take and couple these 2 coils. We have this anomalous generator here that's running 1 coil, and we have the receiver running the other coil. These 2 coils are coupled. Now, does that look like anything we've talked about so far? Let's see how they go. Yeah, this goes down to the capacitor here. This goes to ground. Oops, I got that wrong here. There we go. This goes to the load. That goes to ground. This is an open coil that's driven by a closed coil and some sort of power supply that's feeding something into a capacitor, and this energy is going to be utilized by an inductive load. Consider this part of the circuit here, those coupled floating flux field conductors in that gray motor. This is the storage capacitor. This is the load. Now here's an interesting part that if you've really closely read all those Tesla patents, he says you can hook his transmitter and receiver to ground, which is convenient, or you can hook it to a battery. Now this is where I think it's interesting. Hook it to a battery that's open. I don't know how that works or if it does works, but that's what he said. And it seems from what I've heard that a battery was important in this technology. That would explain how you got rid of the ground. You just use the ion flood in those positive plates.
The battery is not grounded?
The battery is not grounded. It's actually grounded in the machine. It hooks to the case, but it doesn't go to ground. Essentially, the circuit is an open circuit.
So it's a floating ground.
It's a floating ground, yeah. Well, not even a ground. I don't know what you'd call it.
Well, it's a virtual ground.
Virtual ground, something. Because we can't have a whole lot of classical current flowing back and forth in this thing. But, So we start with this circuit. That's the combination, speculative combination of two Tesla circuits that fit the topology of the Gray system. Now if we add the Eric Dollard stuff to that, which we know generated something that was weird, we get something like, well, instead of this part here, we get the diathermy machine that hooks to these two speculated coils. We have to make some more room here. Let me see here. We're going to put a diode here. Reverse diode has no impact on it. We're going to go to the Alexanderson coil that he had. Then a spark gap of some sort, either in a tube or a spark plug. I suspect that Cole used spark plugs because when this engine operated, it made a hellacious noise. A little pop, 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 pop. And when it got going, it was just a roar.
Well, depending on what you mean, I didn't go anywhere physically. However,
To the battery, like that. And then we take this off for a load. This is kind of what's implied if we make a hybrid between the Tesla stuff and the Eric Dollard stuff. But it fits the historical pattern and what was left of the schematic. We got this. Now the next thing is to just swap. These are all series components here, so take the liberty to swap the order in which these things take place. So now we hit the capacitor first, then we hit the coil, loading coil as he calls it, then we hit a spark gap or something, maybe a neon tube or something with some ions in it, kind of like what Maury King works with. And that's a hybridization between the Dollard circuit and the Tesla circuit. Now we take this and just mirror image it so we have two of them. Put a diode over here. Put another power supply over here. We put another collection of stuff here, which is the capacitor, the loading coil, the plasma tube, whatever that's going to turn out to be. Hook these together and use the battery in common. What we have here is a push-pull circuit, which is the only thing that I've been able to come up with that explains the topology of what has been observed and what historically was patented or disclosed. I maintain that the dielectric in here is where the action is. It's being squeezed. This one transmits, this circuit receives, this one transmits, this one receives, and that's why it needed those out-of-phase high-voltage pulses. When this thing hits a pulse, it goes through the diode, but the transmitter resonates at 2.5 megahertz or whatever the Lamar frequency is of the chosen dielectric.
Does it have anything to do with what John talks about on a buck boost type
I'm
setup?
not familiar with his technology
Okay.
enough. I'm pretty sure that his design is generating the same energy that this design is, but this one has the potential to be thousands of times more powerful.
Okay.
And that's where I'm at. I'll be researching the single variation of that now that I got all the stuff to do it. And some of those components are hard to get. That little NE34 lamp is like $50, and the IB22 spark gaps are like $22 a piece. This thing cost $1,000.
Are
It
you,
actually showed up on eBay.
are you on the energetic forum with Eric Dollard, Peter Lindemann?
Yeah, when I've got something worthwhile to talk about.
Okay. What's your avatar?
Spokane one.
Okay.
So you said it takes 12 components. Could you name off those?
These are the components right here.
That's all.
The diode, the floating flux field, the capacitor, an inductor, and an arc tube or a plasma tube or something. It could have been just a regular spark plug. So these, the transformers we know were custom built, but that was just to provide the right waveform and the high voltage isolation. If indeed this thing here generated 100 kV like it is suspected from the historical observations, that means this transformer has to have a whole lot of insulation on the secondary. And this diode's got to really be hefty to handle that.
That battery on the, is that battery an open battery connection, just connected to the positive on the battery?
It could be connected to the negative for all I know, but the battery is part of it, and this is what Tesla said about his systems. You could use the battery for an electron sink. So this has yet to be tested. I'm really out on a limb here, making all these speculations with absolutely no experimental evidence to move forward. So,
Yeah.
so just take it with a grain of salt. You can try it out, and in a few months I'll have more information to share.
You put your battery in a polycarbonate box.
Yes, but I'm not. But here's how to go forward with this stuff, or this is how I plan to go forward with it. I don't plan to build a rotary converter. That's very expensive. I went and bought a vertical mill so I could do that sort of thing, but I think it's more productive to get right to the heart of the matter. What I've built, the first version, is a little platform made out of a cheese cutting table with a 1/2-inch rod in it. And since I work for Simplex Time Recorder Company, they had clocks. They throw away a lot of used clock motors, and that clock motor, you can get a little coil out of it that's already built to go on the bottom here, with a 5/8 hole in the center so it fits the 1/2-inch rod just fine. So I put another one on there. Then I go out to a magnetic contactor to run these two coils, which I can either hook up in parallel or series. They seem to work better in series. And there's a long, I got a little cord out here with loop-de-loop that comes down to this one. So this one can move up and down.
That was you I saw on YouTube. Are you on YouTube?
No.
Somebody's firing coils like that.
Oh, I'm sure a lot of people are. More power to them. Maybe they can find something. This is being used as an instrument. I got a little piece of paper here that you can make out of a business card. It's just 2 1/2-inch strips taped together at the ends. You set it on the rod. When this thing pops, takes the little piece of card up there, and then it stays up there when it comes back down. So you can take your ruler and measure this distance here. Whatever it is, with whatever you've put in this capacitor. Now I happen to have a 5,000 volt fluke power supply, so I can charge this capacitor up with anything from 500 to 5,000 volts. And then hopefully I'm going to build this magic converter with the dielectrics and all the stuff we've talked about, and I'm going to charge up that same capacitor. Well, the simple proof of the pudding is, does the energy that comes out of my new yet-to-be-built converter have any better performance than what comes out of my fluke 5,000 volt power supply? The proof of the pudding will be the increase in height of what this thing travels without having to build a rotary converter. And that's what we're after. We're after particles that somehow, when they run through opposing coils, generate huge magnetic repulsive forces. I think, and also there could be some classical electricity in there mixed with these anomalous particles. I don't know if they're antagonistic to each other or if they one breaks down into the other. Who knows what the physics are? I'll let the theoretical physicists argue about that after I actually see some technical proof of their existence.
Where are you based out of?
Spokane.
Do you have a business card?
No, our company just got bought, so they're going to change all the business cards. But I'll be glad to give you my email address.
Thanks, Mark.
Do you have any handout?
Overall, the technology starts with a classical power supply. It goes in and charges a capacitor. And then it goes to run a motor. This is classical. This is classical. Everything that is non-classical takes place right here. Now, he was claiming to generate cold electricity. Whatever cold electricity is, it can be stored in a capacitor. It's not a wave, it's not a scalar wave. because I don't believe you can store scale. So some sort of anomalous particle was being developed in this technology that was storable, and from the speed of the motor, like it had a lifetime of at least 30 milliseconds. So you can store it for that length of time. Actually, there's indication they last as long as 30 milliseconds. One of the experiments is the popping coil approach. It took 30 seconds to charge the capacitor up with enough of this energy to make the popping coil thing work. So 30 milliseconds is a minimum, but it could have lasted at least as long as 30 seconds. So we're putting something into this capacitor. Okay, now the patent making this is a little more complex than what it looks like. The patent. Oh, thank you. The original 1973 patent involved 2 power supplies, which were center tapped high voltage coils. It went out to diodes. This is what's disclosed, but this isn't everything that's there. They went to these 2 coils, then they went to the capacitors that were alleged to be tied together like this. Okay, and then from here we have the switches that finally went to the utilization.
Straight over the shaft. Put your hands, Aaron. All right, I'm Joseph Newman, and we're going to have some young people here with us from North Texas University. This is Aaron. Diane's going to be assisting him. She's going to be a teacher, and Aaron's going to get the idea of the power it takes to even move the shaft of this 7,500 pound motor. And Aaron's going to pick it straight up with one hand, straight over the shaft. Put your hands straight over it. You're going to just do a curl. Go through. And you can see how hard that is, and that's good. All right, and what I want is your honest opinion. What do you think the chances are the current out of this battery is going to run that motor?
I'd probably say impossible myself.
Okay, all right, good. And that's what I want people to understand. It is impossible by conventional wisdom. that this can happen. All right, now this is from the Energizer that you can pull up on the internet. They tell you a toy is a high drain device. See it in black here? Mm-hmm. Now what they're really telling you is don't put this toy, and here's a toy motor. That's a toy motor. This is a toy they're talking about. Feel the weight of that. That's nothing to it. Now here's the smoke detector. It shows you a 9-volt battery. And this is what the manufacturer of this battery is saying this is what we recommend that you use. A garage opener, a clock radio, or a smoke detector. They say even a baby monitor is a pretty high drain device. And that little toy motor that you're holding is a high drain device. Now you won't see a 9-volt battery do anything of any work. So how are we going to even move this 7,500 pound motor hooked to that 375 pound mud pump? Because we'll take a 9-volt battery that I've got right here that's brand new. Now what I want to do is just verify this is a brand new battery. And it's going to show 9.5 volts. Y'all see it? 9.5 volts. A brand new battery. All right, now let's take it and hook it to a little DC motor. Now this has got a pump on it, but all it is just a little tiny propeller in here, which is nothing compared to this big 375 pound mud pump you see back here. All right, now watch the meter, because I'm going to touch this and it just will move this little pump, just real slow. Now watch how that volts falls. You see it? It's dead. The battery is dead. What's you reading?
It's like 1.3,
1.4.
It keeps moving around.
Yep. All right, but see, you killed the battery. And not only that, this battery is getting warm right now. One of these little batteries, and it's going to run that 7,500 pound machine. Let me just hold it up here against it and get an idea of how tiny it is. Now I'm going to show y'all something that proves this to the lay people. This is a blow up from the Granger catalog. Now look at something. I've got it marked in yellow. Watch a 1 horsepower. This is the amps, 4.4 amps. You saw that little white DC motor. Killed that the instant I even touched it to it. Now this motor here draws 4.4 amps and 230 volts to 460 volts. All right, now let's go down to a 10 horsepower. A 10 horsepower draws 25.2 amps. Notice something, it weighs 360 pounds. This 1 horsepower motor weighed 89 pounds. So the mass gets bigger and bigger. For the horsepower, let's go to 50 horsepower. Now it's 57 amps, and it weighs 636 pounds. Now look at that water. One battery. This is totally impossible by conventional technology. This meter is running negative. It will change the world. Let me read a quote to you. John Kennedy. This is his quote in 1961. If we could ever completely at a cheap rate get fresh water from salt water, this would be in the long-range interest of humanity, which could really dwarf any other scientific
energy device. Your invention works, but your description of the invention is inadequate. And finally, your description.
Tell you what, we could stay here all night.
Railback Battery Company is working with me now trying to design a battery to hold up to this recharging effect of the system. Because not only will it run the device, it'll put more energy back into the battery pack than came out of it.
So you could, that's fascinating. Tell you what, we could stay here all night. We are back. Would you welcome, please, Joseph Newman. Nice to meet you.
I appreciate you having me.
Do you think your machine, if it can be commercially made available, can, for example, a person would buy a 300 or 400 pound unit and all of a sudden would be able to produce all of the energy they need for their home? Is that certainly within the realm of possibility?
Exactly. I have absolutely no doubt about it. That such a device hooked to a home, a person will never have to pay for energy again. The device will be made smaller as to put in an automobile, plane, spacecraft, you name it. This device.
Using the atoms from the magnetic field.
And what you're doing is that you're converting mass into energy on a 100% conversion process. That's one of the first prototypes, and that's a 700-pound magnetic rotor, and it's got about 8,000 pounds of wire around it. That's gone down. That unit there weighs 135 pounds, and they showed that at the Hilton in New Orleans.
Generador 10 Haynes. Motor trifásico 3/4 de caballo. Alambrado a 220 voltios. Capacitor.
Hey guys, I've always been interested in the Thane-Hines Regenex experiments, and so I constructed a pretty large-scale model of what he is. This wheel right here is about 27 inches in diameter, and it's got 60 1-inch by 1-inch cylinder magnets in a north-south configuration, and they're N42s. And then down here I have a coil. 21 gauge bifilar wound coil, connected the way Tesla connected is in his patent. And then in the back here, I have 1 horsepower 3-phase . Hey guys, I've always been interested in the Thane-Hines Regenex experiments, and so I constructed a pretty
thing though is it's a DC glow, but that's because I'm holding on. I see, holding on to one terminal.
Blinds.
Hey guys, I've always been interested in the Thane-Hines RegenX experiments, and so I constructed a pretty large-scale model of what he is. This wheel right here is about 27 inches in diameter, and it's got 60 1-inch by 1-inch cylinder magnets in a north-south configuration. And they're N42s. And then down here, I have a coil, 21 gauge bifilar wound coil, connected the way Tesla connected his in his patent. And then in the back here, I have 1 horsepower, 3-phase, 3600 RPM, 230 460 volt motor. And here you can see it. It's connected directly to a Tico Westinghouse FM50 variable frequency drive. And then back here, I have a laser tachometer, and that points to this little reflective tape right here. And then this way, I can get a speed reading here on my little netbook. And then in the back on the wall right here, I have a power meter plugged in. And so the variable frequency drive is directly plugged into the power meter so that I can measure my input power directly into the motor. So, and then later on, I'll hook up the oscilloscope and show you guys what the waveform looks like. Okay, so this wheel is actually really quite heavy. I think it weighs somewhere between 30 and 50 pounds. So it takes quite a while to spin up to speed. And so I'll spare you the spin up length, and I'm just going to cut in and out of the video for the different results. So what I'm going to do here is I'm going to spin the motor up to 25 hertz, 25 hertz input frequency. And that seems to be about the cutoff point for when after speed increases after that, you start to see the regenerative acceleration effect. And then after that, I'll take it up to 30 hertz and then take some measurements, and you guys can see what the results look like. Okay, so the disc is spinning now at 25 hertz input frequency, and the switch is open, and my speed is about 1454 RPM, and my input watts is about 179 watts. So now if I take this coil and short it, you can see the input wattage really hasn't changed, and the speed really hasn't really changed either. So now I'm going to take it up to an input frequency of 30 hertz, and then we'll do the exact same experiment. Okay, so now it's spinning at...
Recently. Hello, my name is Thane-Hines, president of Potential Difference, Inc. And today we're doing a update video on the bitoroid transformer. So the bitoroid transformer is a new type of transformer that uses purely reactive power in the primary, but delivers real power to the loads. And here we have the output of the transformer. Can you come in and just so people can see that here we have the voltage across our 2 light bulbs and the current flowing through our 2 light bulbs, which indicates there's power being sent to these purely resistive loads. And our power factor on the primary of our transformer is 0. It's fluctuating. It's obviously not 1. And down here we have the current and voltage sine wave. The red sine wave is the power sine wave, and this shows that the power that's coming in on one cycle is being returned back to the source on the other cycle, and the voltage and current are 90 degrees out of phase, which means that the power factor of our primary is 0, and all of the power that's being consumed in the primary is reactive power, meaning the net consumption is 0. So here we have the bitoroid transformer with the primary in the middle. We have secondary 1 and secondary 2. Right now, the 2 secondary coils are on load, and the secondary induced flux from secondary 1 travels into secondary 2 in this direction, and secondary 2 does the same thing. There's no flux, no secondary induced flux coupling back through the primary, and this is why the power factor of the primary is 0. And so when we put the bitoroid transformer on no load, nothing changes. Or rather, when we put the bitoroid transformer on load from no load, there's absolutely no change in the input to the primary of the bitoroid transformer, and because there's no secondary flux coupling back through the primary, affecting the performance of the primary from no load to on load. So we're going to compare this performance to a conventional transformer, which mirrors the load power factor in the primary. So when we put the conventional transformer on load, we will see a very different power factor. So here we have the conventional transformer is on load. The power factor in the primary, the power factor, can you just show the light bulbs again? The power factor of the load is 1. That's transferred back to the primary of the conventional transformer, and it's reflected in the primary. So now we have the voltage in the primary times the current in the primary times 1, and we have real power being consumed in the primary of our conventional transformer and real power being delivered to the load. And if we look at the sine wave, we can verify what the meter says, where the current and voltage are now in phase. The power sine wave is all above the middle line, denoting that all of the power that's being consumed in the primary is real power and that the power factor is 1. So now I'll put it back on the bit again so we can have a quick check here. So there's our bit on load again. Sorry, we have power flowing to our loads. The power factor in the bit is 0, and you can excuse that that meter fluctuating. That's the grid voltage, which is causing the that power factor to jump to 1, but it's obviously not 1. So we're using this meter in conjunction with the oscilloscope to confirm that that both meters are saying the same thing, and in fact they are. So the conventional transformer, when it's on no load, it's consuming reactive power. When it's placed on load, the primary then consumes real power and delivers real power. The bi-toroid transformer, on the other hand, when it's on no load, it's consuming reactive power. And reactive power means that pure reactive power has a 0 power factor. And this is what we have in the bi-toroid transformer on no load. And then when we place it on load, there's absolutely no change. We are now sending power to our load, and the primary of the bi-toroid transformer is completely unaffected. So to go over just a little bit of transformer basics for you, here we have the conventional transformer that is on no load. There's no load connected to the secondary. The primary delivers flux to the secondary and induces a voltage in the secondary. The primary voltage and current are 90 degrees out of phase. That means the cosine of 90 degrees is 0, and the power in the primary is the voltage times the current times the 0, which is 0 watts. The power in the primary is evenly distributed, equally on the top and on the bottom, and this indicates that the incoming power on one half of the cycle is being returned on the other half. When the conventional transformer is placed on load, two very important things occur. First of all, the secondary coil of the transformer has current flowing in it, and it induces a flux which couples back through the primary. This magnetic flux lowers the impedance of the primary and causes the primary current to increase. And the other important performance feature of a conventional transformer is the load power factor, and in this case, a load power factor of 1, is transferred back to the primary. So when the conventional transformer is on load, the voltage and the current are in phase, and the power consumed in the transformer is real power, and it has a real cost associated with it. Now, the bi-toroid transformer is very different in its operation. On no load, here we have a bi-toroid transformer that's on load, but on no load, the primary delivers its flux to both of the coils simultaneously. When secondary 1 and secondary 2 are placed on load, the induced flux from secondary 1 does not go through the primary. It travels in this direction through secondary 2, in this direction through secondary 2, and secondary 2 does the same thing. So we have 0 flux coupling back through the primary, and this means that the load power factor cannot be transferred back to the primary, and the current in the primary does not go up when the bi-toroid transformer is placed on load, because it's only the secondary flux when coupling back into the primary that can change the performance of the primary from no load to on load. In the bi-toroid transformer, because there is no secondary flux in the primary, the voltage and current are 90 degrees out of phase, and the net power in the primary is 0, and the bi-toroid transformer uses pure reactive power in the primary, but delivers real power to the loads, whereas the conventional transformer uses real power in the primary and delivers real power to the secondaries to the load, from the secondary to the load. And the bitoroid transformer, again, on the other hand, uses reactive power with a net power consumption of 0 watts. All for now. Thank you very much.